welcome to another video tutorial of GRE Quant. This is the third lesson on ratios, and in this lesson we're going to be discussing about alligation and how we can solve questions based on ratios with the help of alligation. Let us begin with our today's lesson. Let us start our today's tutorial with the meaning of alligation. Alligation is a method of solving arithmetic problems related to mixtures of ingredients. Alligation is a rapid arithmetic method used to solve problems that involve mixing two products of different strengths to form a product having a desired intermediate strength. Now let us see the connection between weighted average and alligation with the help of an example. Let's suppose we have 100 cows with an average weight of 20 pounds and 50 horses with an average weight of 60 pounds. Now, in order to find the average weight of cows and horses, we're going to use a formula that is average is equal to N1 into A1 plus N2 into A2 divided by N1 plus N2, where N1 is the number of cows, N2 is the number of horses, A1 is the average weight of cows, and A2 is the average weight of horses. If we put these values in the formula, we're going to get 33.33 pounds as our weighted average. Now this means that the weight, which is 33.33 pounds, it is near or close to 20 pounds, that is the average weight of the cows. It is because the number of cows is double than the number of horses. So you see how this weighted average works. Now if we temper the same equation, we can get the formula for alligation, which is N1 over N2 is equal to A minus A2 over A1 minus A. Now this is, through this formula we can find out the ratio of two values, right? Let us move to our next slide. Now weighted average is similar to an ordinary arithmetic mean, except that instead of each of the data points contributing equally to the final average, some data points contribute more than others. Now let's suppose if we have been given the average weight of boys, that is 20 kgs, that of girls equal to 25 kgs, the average weight of boys and girls to be 24 kgs, and we've been asked to find out the ratio of boys to girls. What we're going to do is we can apply two methods for solving our question, right? One is to put the values in the equation, right? And the second method is to make a chart and to simply subtract the average, the combined average from the first and the second average to get the ratio of boys and the ratio of girls, right? So if we subtract 24, that is our average, combined average, by 20, that is our average weight of boys, we're going to get the ratio of girls, which is 4. And if we subtract 24 by the average weight of girls, that is 25, we're going to get 1. So our ratio of boys to girls would be 1 to 4, right? 1:4. So 1 boy for 4 girls, right? Okay, this is another question on weighted average, and it says that the average height of girls is 156 centimeters and that of boys is 174 centimeters. If the average height of all the class is 160 centimeters, calculate the ratio of boys to girls in the class. Now, you see, wherever two values are involved, you know, there are two values, and we have to either find the ratio of the two values or the average of two values, we'll be using alligation, right? So over here, let A1 be equal to 156 centimeters, let A2 be equal to 174 centimeters, and A, that is the average of the average height of all the class, be equal to 160 centimeters. Now what we're going to do is we can solve the question with the help of either of the two methods. If we put the values in the chart, what we're going to get is our ratio of girls to boys would be 7 to 2. Now you see the question says, and that is the twist in this question, it says it is asking us to calculate the ratio of boys to girls, but we have the ratio of girls to boys as 7 to 2. So what we're going to do is we're going to write it the other way around, and our answer would be 2 ratio 7. That is, the ratio of boys to girls would be 2 to 7, right? Okay, we're now going to be discussing about mixtures, and the important thing to note is that when two things are mixed together and they make one thing, it is an alligation question. So you've been given a hint on how to identify an alligation question, right? Now let us come to the question, which says that John has a solution which has 60% concentrated sulfuric acid, Jill's solution contains 90% water, and rest is sulfuric acid, which means 100 minus 90 is 10. So we have 10% sulfuric acid in Jill's solution. They both mix their solutions. The resultant concentration is 40%. Calculate the ratio in which the solution was mixed, right? So John's sulfuric acid is 60%, Jill's sulfuric acid is 10%, and the resultant concentration is 40%. So if we put the values in our chart, what we're going to get is we're going to subtract 60 by 40, right? The concentration of sulfuric acid in John's solution by the resultant concentration, and 60 minus 40 is 20, and we're going to do the same with Jill's concentration. We're going to subtract Jill's concentration of sulfuric acid by the resultant concentration, that is 40, get 30, and the ratio in which the solution was mixed is 3 ratio 2, right? And the important thing to note is that the answer will be the same whether you take sulfuric acid or water to solve the question, right? Easy. Now we have another question on mixture, and it says that seed mixture X is 40% ryegrass and 60% bluegrass by weight. Seed mixture Y is 25% ryegrass and 75% fescue. If a mixture of X and Y contains 30% ryegrass, what percent of the weight of this mixture is X? Now you see, we are supposed to find out the weight of X in the mixture and the percentage weight of the mixture, right? So be careful when reading the question and what you're supposed to be solving for a question. So we're going to follow the same pattern, that is the pattern for solving allocation questions. We're going to put the values in the chart. So we're going to write down the percentage of ryegrass for X and Y, and then the percentage of ryegrass in the mixture, which is 30. So 40 minus 30 is 10, and 25 minus 30 is 5. So we get the ryegrass ratio of X and Y to be 1 to 2, right? Now what we're going to do is, you see, the ratio, the total ratio has 3 parts, and the ratio of X is 1. So we're going to divide 1 by 3, because you see the ratio of X is 1/3 of the total, right? So the ratio of X is 1 by 3 of the mixture. And in order to find out the percent of the weight of the mixture, we're simply going to multiply 1 by 3 with 100 to get 33.33%, which is the percentage of the weight of X, right? Okay, with this we come to the end of our third lesson on ratios. I hope you've understood the concept of alligation and how we solve for a question using this technique. Now in the upcoming videos I'm going to be uploading more questions related to alligation and to make the concept and the technique of alligation more clearer to you. So stay tuned to this channel, be positive, and keep your spirits high. You know, you can do it. Anyone can do it. So you can do it too. So goodbye for now, and thank you very much.